All right, we're getting ourselves ready for the Unit 7 quiz/test. So we're going to take a look back at some of the things we've done with probability and make sure we get a good grip on this moving ahead. So the first one, a little adjustment here, design an experiment with a control and experiment group. Identify which is the control and which is the experiment. This is where you're actually making up a problem in here. So I'll do one similar to the one that I talked about in class before. So let's say we take 2 algebra classes. One gets a review, one doesn't, and then take a look at the grades after. Now, you don't have to use the one that I'm using here, but it lets me see okay, again, there's my control group, my group that doesn't get a review. There's my experiment or treated group that does get one. So that's how I experiment. I'm choosing who gets a review and who doesn't. So that's the experiment part, because I'm not just watching to see what they do. And then again, control group we didn't change, experiment or treated group we did, and that's all I'm doing. So I'm going to have to get a little creative here, think a little bit. All right, let's see here. Number 2. I'm going to give a survey to high school students about how I'm doing as a teacher. Oh, that's dangerous. I plan on only giving the survey to students who have A's. Is this appropriate? So is this biased? Unfortunately, no, this is not appropriate. It's biased. So how would you describe the technique? Or in other words, what could I do to get a better general feeling of how I'm doing as a teacher instead of just giving my survey to the A students? Maybe give my survey to all of my students. It's not like there's thousands of them. I could still get to an answer that way. That's something I could look at. Okay, or you could describe why my technique is bad. Either one of those would be perfectly acceptable on a problem like that. So then on number 3, we've got 2 letters are selected at random from the word ideas. What's the probability of selecting 2 vowels? So remember, it's successes over the total. So I go, okay, there's a total of 5 letters. How many of my letters are currently vowels? 1, 2, 3 of them. So when I select my first letter, there's a 3 out of 5 chance I'm going to get a vowel. Okay? But that's not the question. The question is, what's the probability of selecting 2 vowels? So let's go under the assumption on this first one that I got one of those 3. Okay? So when I go to pick a second letter, how many letters total are left? Now there's only 4, because I can't have the same letter twice. And if I got a vowel the first time, how many vowels are left now? So if we say we got I the first time, I'd still have E and A, so there'd still be a 2 out of 4 chance. And then like we do with all probability, we just multiply across and simplify the fraction as far as we can. Now if you went to a decimal, if you had 0.3, I won't jump up and down and scream it. Most of the time we're just going to leave those in fractional form to make those look that way. 4. The relative frequency histogram shows the distribution of the number of tails when 2 coins are tossed. Find the probability of getting 2 tails. Okay, well, let's see. There's 2 tails. If I look at the chart, 2 tails, 1/4 of a chance. Because again, it makes sense because when I flip a coin, I could get heads and heads. I could get tails and tails. I could get heads and then tails. I could get tails and then heads. Those are the only 4 options there are. So how many of them have 2 tails? 1 out of 4. So I can look at it this way, the chart, whatever works best for me. So we keep rolling along here. You're like, this isn't bad so far, and it's not. A bag of jelly beans contains 5 red, 7 green, and 4 blue. What's the probability that you get 2 greens without replacement? Okay. Well, first I got to know how many total jelly beans there are, because again, I got to know what my chances are going to be. So 5 plus 7 plus 4 is 16. And I'm looking for a green one, so my success would be the green one. So there's 7 of those. But again, without replacement, it's kind of like what we did in number 3. If I took a green jelly bean, let's say I popped it in my mouth and ate it, well, now I've only got 15 jelly beans left. And if I just popped that first green one in my mouth, it means now there's not 7, there's only 6. And again, I'd multiply across with this, but I want to make sure that when I do that, that I reduce that fraction down as far as I can. Good old math enter can come in handy for me when I'm doing something like that. So I keep going. All right. When rolling a die, what's the probability of rolling a 5 or a number greater than 3? Now this gets a little bit trickier because I got 2 different things going on. So I go, okay, what's the probability of rolling a 5? Well, there's 6 chances, and my chance of rolling a 5 is 1 out of 6. You're like, okay. Then I look at this next part. A number greater than 3, 4, 5, or 6. You're like, now wait a minute, why are you adding? I thought we said when we did probability we always multiply. Well, when I have this or in here, okay, because I can't have both of those things going on at once, I want to see, what my chances are of some things. So I look and I go, okay, so rolling a 5 is 1 out of 6. Greater than 3 is 3 out of 6. But wait a second. Is there something that repeats? Yeah. My 5 repeats. I rolled a 5, but 5 is also included in here. Well, I can't count it twice. So I take it back out. So 1 plus 3 is 4 minus 1 is 3 out of 6 or 1/2. Kind of strange on that one. I got to be a little bit cautious on a problem like this just to see how it's happening. But again, it's that little fancy word in the middle, or. Okay. So you're like, okay, it's a little odd, but I can still handle this. So let's see here. Okay, 7. A die is rolled. Find the probability of getting 1 or 5 or 6. Okay, there's those ors again, which basically are going to be pluses for me. So my chance of getting a 1, is 1 out of 6. Getting a 5, 1 out of 6. Getting a 6, 1 out of 6. Which is 3 out of 6 or 1/2. You're like, do I have to show all this? Because, can't you sort of figure out there's 3 numbers, it'd be 3 out of 6? Sure. But again, I like you seeing where it's coming from. But it's just one option that I have. Like, I suppose. All right. Betty's going to make a sandwich. There's 4 types of bread, 5 types of meat, and 3 types of cheese. How many sandwiches can she make if she's going to choose 1 type of bread, 1 type of meat, and 1 type of cheese? Okay, so we've got bread, we've got meat, we got cheese, and it's not 1 times 1 times 1. It's how many choices do I have for each. There's 4 types of bread. There's 5 types of meat. There's 3 types of cheese. And I multiply my options together. Straight up fundamental counting principle. And then the same thing's going to happen on number 9. So Ben's going to watch a comedy, a horror film, and a foreign film this weekend. How many ways can he order his movie marathon? Okay. So we've got movie 1, movie 2, and movie 3. So when I get to my first movie, I have 1, 2, 3 choices. But if I watch the comedy first, now when I get to the second one, I have a choice between the foreign and the horror film, and then I have no choices left at the end. And I can get to my answer. Again, do I have to have the blanks? No. But if you get confused, sometimes putting them there can kind of put your thoughts into a little more organized fashion. All right. 2 letters are selected from the word breaks. What's the probability of getting 2 vowels? Okay, 2 letters. Breaks. I'm noticing here there's 6 letters. How many of them are vowels? 1, 2 of them. All right. And then I look and I say, okay, so if I picked A with the first one, it's sort of like, think about it as you've got all these letters on cards in a hat. So you draw in, you pull out A. She's like, okay, I pulled out A. How many cards do I have left in the hat? 5. How many vowels do I have left? 1. Sort of lets you visualize what's going on. And I find out my probability isn't real good. All right. Dice. We've talked about dice before and how every one of those rolls are independent of one another. It's not like when I'm picking one of these and one disappears. So, what's the probability that both die will roll a 5? Okay, I'm doing them separately though. If I roll a die, what's my chances of getting a 5? 1 out of 6. If I grab a die and I roll it too, what's my chances of getting a 5? The same thing. It's not like the 5 went away or there are less choices now with a die. So I have to pay attention to the situation a little bit. And I get my 1 over 36. So then I look and I go, okay, coins tossed 4 times. What's the probability of getting 4 tails? Okay, so I have 4 situations going on here. If I want to, I guess I could call it toss 1, toss 2, toss 3, toss 4 if I wanted to. And then again, independent situations. I flip a coin. What's the chance of it coming up tails? 1 out of 2. Okay, I pick the coin back up. I toss it again. What's my chance of getting tails? You're like, okay, Harty, I get it already. So each time, my probability is going to be 1/2. And I just multiply all of those together. Again, independent situations, but I go ahead and can multiply them together to find my probability. All right. Rhonda, Jenna, Brian, and Aaron are going to a teaching conference. The principal only wants 2 of them to present on Monday. If everyone is equally likely to present, what are the possible teams? Now, what I normally would do is I like to visualize this. I like a picture. So I'm going to take Rhonda, and I'm going to say, okay, Rhonda could team with Jenna. Rhonda could team with Brian. Or Rhonda could team with Aaron. So then I'm like, okay, but what if Rhonda's not in the group? Okay, let me move to the next person in the list here, which would be Jenna. Okay, now Jenna's already teamed with Rhonda here, so I can't do that one again. But she could team with Brian or Aaron. So I'm like, are there any other possibilities? Well, there are. Because then I go to Brian, and I go, okay, now Brian's already teamed with Jenna, already teamed with Rhonda, but there hasn't been a Brian-Aaron combination here. So I notice there's 1, 2, 3, 4, 5, 6 possibilities. So the probability of Brian and Rhonda being a team, I can even just look at my graph now, 1 chance out of 6. How many people could team with Aaron? Well, let's see. 1, 2, 3. 3 out of 6. 1 out of 2 chance you're teaming with Aaron. A team without Brian. Okay, let's see. There's a team without Brian. There's a team without Brian. There's a team without Brian. There's 3 of those. So you see the benefit in drawing the picture when you're doing this, so you can visually see how this is going to work. And just write down those possible combinations and do it that way. Now, some of you probably can visualize that in your head. That's just not how I normally work, but hey, to each their own. All right. If a couple is planning on having 3 children, what's the probability that all 3 are girls? Okay. So let's see. I got baby 1, baby 2, baby 3. What's the chance of getting a girl the first time you have a baby? Last I checked, that'd be 1 out of 2. Baby number 2, 1 out of 2. 1 out of 2. And I put 1 out of 8. So we're going to keep peeking at some of these, kind of seeing how we can make some connections with some of the stuff that we've done. Okay, so we're like, all right, so the math team has 8 juniors and 13 seniors. There are 5 junior females and 6 senior females. Now, I notice that doesn't add up right, because there's 8 juniors, there's 5 females. So let's finish this. There's 3 males. If there's 13 and 6 of them are females, there's 7 males. So I can get all my information that I need this way. Oh, there's that blasted word "or" again. Okay, 2 separate things going on with these. So I go, the probability of being a senior. Okay. So there's 13 seniors. How many people are there total? 8 juniors and 20. 8 juniors and 13 seniors. I was thinking ahead a little. Means there's 21 total people. So I get my 21 in there. Okay, so that's my seniors. Plus, how many females are there? There's 5 here and there's 6 here. So that's 11. But what we've got to remember here is that we're going to subtract what's in common, what repeats. So what would be a repeat here? A senior female would be a repeat. So senior females, there's 6. I got to take those back out or they get counted twice. So 24 minus 6 is 18. And I reduce it. And I'll have a reminder up on this during the quiz. I'll say like, ORs do separately, subtract what's in common. So I come back over this way. Probability of a junior. There are 8 juniors. So 8 out of 21. Probability of being a male. 3 and 7 is 10 males. But again, minus what they have in common. A junior male would be what they have in common. Junior male, there's 3. So I gotta take those out. So 18 minus 3 is 15 out of 21. Or 5 out of 7. So it's the same probability we've been doing, it's just we're trying to get that what's in common out of there. Okay, probability of a junior, 8 out of 21, plus the probability of being a senior, 13 out of 21. Do they have anything in common? Well, no, because you can't be a junior and a senior at the same time. So I add them up, and you have to be a junior or a senior in this case, so that takes care of all of them. But again, there will be some assistance available for you on this. But again, the big key is OR is add, and then we just take away what they have in common. All right, the one that we have a more familiarity with than we had those. Use the chart below to answer the following questions. Okay. Oh, there's that word given again. So how does that work again? Okay, remember, the given part is going to be what goes at the bottom. What's going to go up at the top then, and on top here, is what my end result is. So here's how this is going to work. Probability of a male given that they're overweight. So overweight goes on the bottom, and an overweight male is what goes on top, because again, it's about these two things going together. My end result takes both of these into consideration, the overweight and the male part. So I look for overweight males. Male overweight, there's 45. How many total people are overweight? 66. Oops, I didn't reduce that, did I? Take that back, 15 over 22. That's my better answer. Gotta remember the reducing part. Probability of normal weight given they're female. Okay, so female goes in the denominator. And a normal female, I'm not running with that, goes on the top. So I go looking, okay, normal weight female, 14. Females total, 50. And reduce my fraction. And then I get one more in there. Oh. There's that or again. Say. So now it changes up. It's not like the givens were. So probability of overweight. So I have 66 overweight people out of a total of 112 total people. And then female, how many females do we have? We have 50 out of 112. But then I have to minus the ones that would be in common, which are the overweight females, which there's 21 of. And that actually doesn't reduce anymore. So again, the key words are what matters here. If it's given, we do the given part as my denominator, and my end result, those two things together as my numerator. But if it's or, we add the two things up, but we subtract what they have in common. Again, relax. You will have some assistance. All right, and we'll finish up some stuff that's straightforward. If you have 6 CDs, how many ways can you place them on a shelf? So when we do this, okay, so when we're looking at our 6 CDs, how many ways can you place them on the shelf? Well, here's the way I like to look at it. It helps me kind of put it into context a little bit better. As you can see, I'm more of a visual type here. So if I have 6 CDs, how many ways can I place them on a shelf? Okay, how many choices do I have for where I put my first CD? Well, I've got 6. Okay, so that CD's there. Now how many more CDs do I have to choose for the next spot? 5 and 4, and you can see at this point the way that it goes, and I can multiply these together. This actually ends up being a permutation. So if you punch this into your calculator, you do the 6p6 and you get the same answer. Because again, there's an order. Sort of think of it like you do with library books or something. The order matters a little bit on the way that they're stacked in the shelf. So then I look at 20 and I go, okay, in a class of 36 students, how many ways can you choose 4 students to be on a committee? So again, I kind of think about it this way with the blanks. Okay, I got 36 people for the first spot. And then I have 35 and 34 and 33. Now let's think about this one for a second. 36 students, choose 4 for a committee. If it's just a general committee, does my order make a difference? No, which would mean it was probably going to be a combination. So let's see, so 36, choose 4. Okay, now let's see if that, so I did my combination, I got 58, 9, 05. So let's see now if we do this, if we get the same thing. Ooh, I didn't. I wonder if that's the permutation number. Ooh, it is. So we got to think about this for a second. Okay, we're pretty sure it's a combination. So what would be wrong with doing it with the blanks this time? Well, here's my dilemma. When I'm doing this, I'm having some repeats in here. So let's say when I'm doing this, I have a committee, and the first time through, I choose Ryan, Joe, and Michelle, and Jen. When I do a permutation, I could take those same 4 people, just rearrange them, and say, well, now this time I'm picking Joe, Michelle, Jen, and Ryan. But that's really no different. So here, using my permutation idea would not be a good idea. I'm going to go ahead and go with combination. So again, it can get to be a little tricky, but just keep reminding yourself, if there really is no difference at all on how this works, that's something that I'd want to look at. Finally, when building our laptop for college, we choose 4 different screen sizes, 6 different hard drive, and the case color can have a black, silver, alien, green. How many computers can I create? Okay, so I've got screens, I've got hard drives, and I got case colors. 4 different screens, 6 different hard drives, 1, 2, 3 of those. Multiply them together and get 72. So again, we'll be taking a look at a quiz somewhat similar to this tomorrow. We'll chat about your help sheet. Well, probably not going to be a help sheet on this one. Probably just going to be a couple of hints to get you started. But we'll get you ready to go with that then. And if you got any other questions, let me know.